By far the most contradictory factor regarding the South Atlantic anomaly comes from the differing statements from NASA and propagandists. On May 4, 2001, Science at NASA released an article called The Phantom Torso, in which Dr. Gautam Badwar of the Johnson Space Center was interviewed. In the article, we find
some of this trapped radiation is confined to a region above the coast of Brazil, known as the South Atlantic Anomaly. The space station goes through that anomaly roughly 5 times a day, says Badwar. The passage takes at most about 22 or 23 minutes. That's good, he says. If you go through the trapped radiation belt in less than 20 minutes or so, then for the next 70 minutes the body has time to do some repair to the damage done by the radiation. The radiation from solar flares can actually do more harm, he says, simply because it comes at a rate that doesn't give the body time to recover.
This statement from Dr. Badwar was echoed by Mary Bennett in an article she wrote for Ollis Online.
As far as the ISS is concerned, NASA currently considers that 23 minutes of any orbit going within the SAA is acceptable exposure time to radiation. Not only because the ISS is somewhat protected from this radiation, but also because the remaining 70-odd minutes of orbit apparently permits the human body to recuperate from the radiation effects inflicted upon it whilst in the SAA.
Yet on his website, in response to her article, Jay Windley claims that the human body does not have that kind of ability to heal from radiation in a matter of 70 minutes. As he states,
"The human body does not recover from radiation in a matter of minutes, but rather hours and days. The damaged tissue must be regenerated. If radiation exposure is more or less continuous over several days, such as in the shuttle scenario, the tissue never has time to regenerate before being damaged by continuing radiation."
Windley makes no mention of this statement from Badwar, and instead tries to pin this on Mary Bennett. So it seems, the human body can heal over 70 minutes after a 20-minute exposure to the anomaly, as Badwar states, or the human body does not have this ability, as Jay Windley tells us.
If you go through the trapped radiation belt in less than 20 minutes or so, then for the next 70 minutes the body has time to do some repair to the damage done by the radiation.
The human body does not recover from radiation in a matter of minutes, but rather hours and days. The damaged tissue must be regenerated. If radiation exposure is more or less continuous over several days, such as in the shuttle scenario, the tissue never has time to regenerate before being damaged by continuing radiation.
Obviously, one or both of them are lying. Radiation not only affects electronics and living organisms, but also camera film. When Sir Patrick Moore ran his program in the hopes of disproving the conspiracy charges, his guest Douglas Arnold of Kodak had this to say about film exposure to radiation.
Second point is, and people who have had their films X-rayed inadvertently when going abroad will realize this, film is very sensitive to radiation. Now, there is no doubt that the many pictures we've seen from near the moon, if not necessarily on the moon, around the moon, vehicle to vehicle, etc., these show no signs of radiation whatsoever. And of course also, the shuttle astronauts, again, since the early 1980s, have been bringing back tens of thousands of images. They would have been subjected to radiation in the South Atlantic anomaly if it was going to have any effect. No evidence whatsoever.
This is not what Arnold told David Percy in July 1996.
You have an enormous amount of radiation in space, and potentially it affects film, of course, and of course, as you will well know, its prime effect is on contrast.
His explanation for the lack of radiation damage was, quote, The tests that were done indicated that the storing of film magazines in special containers within the CSM, which was itself shielded to some degree from radiation, was obviously enough. However, as Marcus Allen, editor for the magazine Nexus, points out, in 2002, IMAX released their film entitled Space Station 3D. It was a film made entirely about the construction of the International Space Station.
They flew the cameras up in the space shuttle with their magazines attached, and the IMAX cameras take 70mm roll film, incidentally the same film as was used in the Hasselblad still cameras on Apollo.
Mr. Allen directed me to the two following articles. In both of them, the movie's director and producer, Tony Myers, was interviewed. The April 26, 2002 printing of The Telegraph ran an article called "A Truly Star-Studded Movie." In it, we find this statement. Because of the limitations of film, each pound in weight costs millions of dollars to blast into space. The astronauts were limited to shooting less than 2 minutes of film at a time. The astronauts also had to race to shoot the film before it was fogged by the high levels of radiation in space. We had to get the film up to the station, throw it across from the shuttle, shoot it, throw it back to the shuttle, and take it back, all on the same flight to the space station, or it would have been ruined. The April 21st, 2002 printing of the New York Times also featured an article about the production of this movie. Is that a space helmet or just your 3D goggles? Adding to their difficulties, background radiation outside the Earth's atmosphere quickly causes film to fog. Fresh stocks arriving by space shuttle, along with more vital supplies, had to be used in time for the shuttle's return trip, usually within 2 weeks. Thus, filming in the space station coincided with periods of peak activity. In many ways precisely the least convenient time. Not until the final phase of the project were means found to retard radiation damage. Shielding film in bags of water did the trick. Between the shuttle's last 2 visits, 3 precious rolls remained on board the space station. Everything shot on these rolls, Miss Myers says, made the final edit in full, including those aliens. This is in direct agreement to what NASA told us after NOAA 720 exploded, that solar protons with energies greater than 100 million electron volts can burrow through 11 centimeters of water. It seems that the radiation below the Van Allen belts is so severe the film must be protected in water bags, and the film can only be out in open space for 2 minutes before getting fogged by radiation. But on Apollo, the astronauts did not promptly return their Hasselblad film to the LEM after 2 minutes of shooting. In fact, on the J-type Apollo missions, the astronauts ventured miles from their lunar module and spent as much as 7 hours out on the lunar surface. On his website, Jay Windley displays this image from Luna 9, the Russian probe that landed on the moon in 1966. The caption reads,
"The lunar surface as photographed by the Soviet probe Luna 9. The lunar probes used film technology to photograph the lunar environs. The film was not damaged by radiation."
Of course, Windley's image is shrunken in size and doesn't reveal any detail. If we take a look at a high resolution of the photograph, we find that the image is indeed damaged by radiation. Look at the sky. You can see how the black of space appears kind of pale. Now compare these Luna 9 surface images with these photos taken after the Chernobyl nuclear disaster. Both show signs of having been fogged by radiation. which is noticeably absent in the Apollo surface images. Years ago, Dr. David Groves performed an experiment to simulate film exposure to X-rays.